Hi, welcome to R&AC Academy. My name is Ram Prasad. Let me give a small brief about me. I did my masters in R&AC and then I worked for 25 years with the various organizations involving in product development and technology innovation functions. I had 5 patents filed on my name. Out of my passion, I transitioned into teaching. Presently, I am into coaching GATE and IES aspirants on R&AC subject. I also conduct workshop on R&AC systems, faculty development programs, etc. for the engineering colleges. Recently, I conducted webinars for the members of ISHRE and ASHRE. Coming to this program, I am presenting here with a series of lectures on refrigeration systems for the benefit of the students and professionals. I believe these lectures will be of great help and learning to all of you. This is the first lecture in the series of lectures on refrigeration systems. In this lecture, I will introduce you to the subject of refrigeration. Let me start with the definition. Refrigeration is a process of reducing and maintaining the temperature of a space or body below ambient temperature. Here, an interesting question comes to the surface very naturally, and that is there any difference between cooling and refrigeration? Let me explain the answer to this question using some familiar examples from our daily routine. Let us say we are leaving a cup of hot coffee on the table. We all know after some time the temperature of the coffee will be reduced. However, is it possible to have the temperature of this coffee going below ambient temperature? Not possible at all. Hence, the coffee in this case is said to have undergone only cooling process. Let us now take a glass of water. Keep on adding small pieces of ice to it and stir it. After some time, we all know that the temperature of the water will be going below ambient temperature. Hence, the water in this case is said to have undergone the process of refrigeration. To sum it up, any process that reduces the temperature of a space or body is called cooling, and among those cooling processes, the process that reduces the temperature of a space or body below ambient temperature is called refrigeration. The substance that produces refrigeration is called the refrigerant. In this example, between ice and water, ice is the refrigerant. Ice is also called a natural refrigerant because nature can make ice on its own. Ton of refrigeration. It is an interesting unit in the field of R&AC. Actually, ton of refrigeration is a unit of measurement for refrigeration capacity. It is defined as the heat to be removed to freeze 1 ton of water at 0 degrees centigrade into ice at 0 degrees centigrade within 24 hours. By decoding this definition, we can understand that we are given 1 ton of water at 0 degrees centigrade and we need to freeze it into ice at 0 degrees centigrade. What do we need to do for that? We need to remove heat from this water. But by how much? Equal to the latent heat of fusion for 1 ton of water. And we need to remove this much of heat energy from water in 24 hours time. This is how the ton of refrigeration was defined. The original derivation for this unit had happened in British units. So let us start from there. 2000 pounds is equal to 1 ton in British units, and we need to remove the latent heat of fusion from this water, which is equal to 144 BTUs for every pound of water. Therefore, we need to remove these many BTUs of heat in 24 hours time. This would resolve into 12,000 BTUs per hour or 200 BTUs per minute. However, these days we are following SI units. So let us convert it. The conversion here is 1 BTU is equal to 1.055 kilojoules. Therefore, 1 TR is equal to 211 kilojoules per minute or 3.52 kilowatts. Let me put an interesting question to all of you. When did we first hear the word refrigeration during our BTech course? It was during our second year first semester while studying thermodynamics subject. I'm sure all of you will be agreeing with me on this. But my question is, when exactly? We heard the word refrigeration for the first time during our BTech course while discussing second law of thermodynamics, and in that with Clausius statement. What does Clausius statement say? It says that it is impossible to construct a device which, while operating in a cycle, can produce no effect other than transfer of heat from a low temperature body to a high temperature body. Let us first understand what exactly the Clausius statement is communicating to us. As long as we are transferring heat from a high temperature body to a low temperature body, there are no issues. It will happen on its own naturally. But if we want the heat to transfer from a low temperature body to a high temperature body, then it will not happen on its own. We need to supply energy for that to happen. This is what declared by Clausius, and this single statement evolved into a full-blown subject called refrigeration for all of us. Even today, any proposal that violates Clausius statement will be declared as invalid. Such is the significance of Clausius statement. The next. This is how a refrigeration cycle or system is expressed in a block diagram format. You have refrigeration cycle or system R absorbing heat QL from a low temperature body at TL and rejecting heat QH to high temperature body at TH. In the process, it will be taking W amount of energy as its input. Let me explain an interesting perspective here. In the context of thermodynamics, the letter W typically denotes work energy. Then, does it mean that we can produce refrigeration only with the work energy as input? That is question number 1. And if we propose to produce refrigeration using heat energy as input, then will we be violating Clausius statement? This is question number 2. The answer to both question number 1 and 2 is a no. Whenever we are transferring heat from a low temperature body to a high temperature body, we need to supply energy for that to happen. However, there are no restrictions on the type of energy. Hence, our proposal is not violating Clausius statement. But then, do we have any system that is existing at present which can produce refrigeration using heat energy as input? The answer is yes, and the example for that is vapor absorption refrigeration system. On the other hand, the very popular example which produces refrigeration using work energy as input is vapor compression refrigeration system. With this lecture ends, and in case you have any questions, doubts, queries, etc., please feel free to write to me. The next topic in this series is on evolution of refrigeration system. In this lecture, starting from the basic principles of physics, we will be building the complete refrigeration system in a step-by-step manner. See you then. Thank you very much.